So for this question, we have x times by the square root of 2x plus 5, and we need to integrate that with respect to x, okay? But we need to use a substitution of u is equal to 2x plus 5. So how can we solve this using this substitution? Well, first things we can do is we can actually differentiate this u with respect to x. And if we do that, we get a du over dx is equal to 2. Now you're probably wondering, why are we differentiating? We want to integrate, right? Well, actually, we want to change everything in the question to u. And that means that if we want to change everything to u, we want to integrate also with respect to u. Now, right now, we are integrating with respect to x due to this dx here. So we need something in the form of du so we can differentiate with respect to u. Now, doing du over dx gives us that du. And now we can just rearrange this. And if we rearrange this, we would get a dx is equal to a half du. Now we have an expression for du. So now we can change that dx into a half du later on. What else do we know about this question? Well, what else do we know? Well, we also have an x, right? But in our question right now, we need to figure out what x could be in terms of u. So if we just use the fact that we know that u is equal to 2x plus 5, we can just rearrange this to get it to get x by itself. And if we do that, we would get a x is equal to a u minus 5 over 2. And now that we've done that, well, we've now got an expression for x in terms of u. We've got an expression for the 2x plus 5 in terms of u, and we have an expression for that dx in terms of u as well. So now we can just put that all together. And if we do that, what would we get? Well, we would get a x. So we know x is u to the u minus 5 over 2. That is times by the square root of 2x plus 5, which is just the square root of u. And that is times by dx, which is just a half du. And now we can just put this all together and we can work it out. So if I scroll up here, we work this all out. Well, we have a u minus 5 over 2 times by the root u. So if I do that all in one go, what do we get? Well, that u times the root u, that would give us a u to the 3 over 2. And we'd also get a minus 5 root u. I'm going to change that root u to a power of a half, so 5u to the power of a half. And that would be over 2. And that's times by the half du. And then that would just be, if we multiply that, we'd get a u 3 over 2 over 4 minus a 5 over 4 u to the power of a half du. Okay? This is all integrate like so. So now we have this. If I write this a bit better, we have where we need to integrate 1 over 4 u to the 3 over 2 minus 5 over 4 u to the half with respect to u. So this becomes a lot easier now. And if we were to integrate this, what would it be? Well, we would get again, u plus the power, so it's a 1 over 4 u 5 over 2 over 5 over 2 minus a 5 over 4 u 3 over 2 over 3 over 2. Okay, and then we can add the plus c here. And if we work this out, we'll get a 1 over 4 divided by 5 over 2. That is the same as saying 1 over 4 times by 2 over 5. So that would give us a 2 over 20, over 20, u to the 5 over 2. And that'll be minus a 5 over 4 divided by 3 over 2, which is the same as 5 over 4 times by 2 over 3, which will give us a 10 over 12 u 3 over 2. And then we have a plus c. And if you simplify this down, you are left with a 1 over 10 u 5 over 2 minus a 5 over 6 u 3 over 2 plus c. And now at this stage, we can just put back in our value for u. In this case, our value for u was just 2x plus 5. So if we put that back in, it would be a 2x plus 5 all to the power of 5 over 2 over 10. And that would be minus a 5, 2x plus 5 to the power of 3 over 2 over 6 plus c. So for this question, we need to integrate cosine x sine x times 1 plus sine x to the power of 3 with respect to x. We need to integrate that, and we need to do substitution of u is equal to 1 plus sine x. So again, what we can do is we can differentiate that u with respect to x, and if we do that, we get a du over dx is equal to cosine x. Now for this one, it's slightly different, because while we can just bring that du to the other side and just get it and just have dx is equal to 1 over cosine x du, in this case, because we have this cosine x here, it's actually better to write it in this form here. And the form is we actually keep the du here and we bring the dx to the other side. So we get du is equal to cosine x dx. Now, why is this better? Because if you look in our question, what do we have? We actually have a cosine x dx. They might not be next to each other, but we have a cosine x dx right here. That's all being times together. Obviously, the order of the multiplication doesn't matter. So actually, all of that cosine x dx equals du. So that cosine x and dx is taken care of. It just equals du. So we don't need to worry about that. That is taken care of. Now all we need to do is worry about that sine x. How can we get a sine x? Well, a sine x is very simple, because if you look at the question, well, we have u is equal to 1 plus sine x. So just bring that 1 to the other side. That means that we would also have a u minus 1 is equal to a sine x. So now that sine x is taken care of. We can get that sine x in terms of u. We can get the cosine x dx in terms of u. And obviously, from our substitution, we already have the 1 plus sine x in terms of u. So we've done everything we need to do, which means that now we can put it all together. So if we put it all together, well, let's do the sine x first. That would be a u minus 1, okay? And that would be times by that 1 plus sine x cubed. So that would be times by a u cubed, okay? And then that would also be times by the cosine x dx, which we know is just du. And that's it. We've changed that whole trigonometry function into just u's, and it looks a lot more simple. And now all we need to do from here is just multiply this out. So that would give us a u to the 4 minus u to the 3 du. And then we can just integrate this as normal. And if we integrate this, we get a u to the power 5 over 5 minus a u to the power 4 over 4. And that would be a plus c, okay? And now what you can do is we can put back in our original values for u. So we had u was equal to 1 plus sine x. If you put that back in, you get a 1 plus sine x to the power 5 over 5 minus 1 plus sine x to the 4 over 4 plus c. So for this question, we need to, using the substitution of u is equal to cosine x, we need to integrate sine to the 3x cosine squared x, all with respect to x, when we have pi over 3 and 0 as our limits, and that all equals 47 over 480. We need to show that it equals 47 over 480. So the first thing first, if we know that with substitution we have u is equal to cosine x, well, therefore we know we have cosine squared x, so we can just change this to get it into cosine squared x. If we times both sides by itself, we get a u squared is equal to cosine squared x. So the cosine squared x is taken care of. Now the next bit, what we're going to do is we know we need some form of sine x in the question. So we can differentiate u with respect to x, okay? If we do that, what do we get? We get a du over dx, and that is equal to a minus sine x. I'm going to bring that du to the other side, so we get a du is equal to a minus sine x dx, and then we're going to bring that minus to the other side, so we get a minus du is equal to a sine x dx. Now it's looking pretty good so far, because right now we have a sine x and we have the cosine squared x, but we're missing something. If I just rewrite the equation, this is effectively what we have. We have a sine x times a sine squared x times by a cosine squared x dx. So I've just rewritten the question like this. The reason for that is so we can clearly see what we're missing. Now, right now, what we have worked out, we've worked out this, we've worked out the cosine squared x, we've got that in terms of u, so that's fine. We've also worked out the sine x dx as well, that is a minus du. So we've got that, that is perfect. We're just missing that sine squared x. We need some expression of sine squared x in terms of u. So how can we do that? Well, this is what we can do. What do we know about sine squared x and cosine squared x? We know that sine squared x plus cosine squared x, we know that that equals 1, okay? So if we rearrange this to get it in terms of cosine squared x, well, we know that cosine squared x is equal to 1 minus sine squared x. So we can change our cosine squared x into 1 minus sine squared x. So if we do that, we get a u squared is equal to a 1 minus a sine squared x. And then if we rearrange this, we would get a sine squared x, and that would be equal to a 1 minus a u squared. So now we've got everything. We've got an expression for sine x dx in terms of u. We've got an expression for our sine squared x now in terms of u. And we've got an expression for our cosine squared x in terms of u. So now let's put this all over the integral formula. But wait, we are not done yet. There's one thing we haven't done. That is our limits. We have the limits of pi over 3 and 0. Those are in terms of when we're dealing with x. We need to convert that to u values. So to do that, it's very simple. We've got u is equal to cosine x. Just put your values of x into that. And if you do that, you would get a u is equal to cosine pi over 3. Well, that is the same as cosine 60, which is just a half. And we have u is equal to cosine 0, which would just be a 1. Okay, so what does all of this mean? Well, what all of this means is that if we put this all over one integral, we'd have the integral of a half. Remember that with your limits, don't just put the bigger number at the top, the smaller at the bottom. No, that's not how you do it. Whatever that pi over 3 was, whatever your corresponding value, keep it in the same place. Just keep it all in the same place, keep it simple. So we get a half and we get a 1. And then we have, let's do the sine squared x. So we have a 1 minus a u squared, 1 minus u squared, that is times by the cosine squared x, which is just a u squared, okay? And that is times by the sine x dx, which is a minus du, okay? And if we were to work all of this out, what do we get? Well, we would get a u squared minus a u to the 4, okay? And then we also need to times all of this. All of that as well, we're getting times by that minus du as well, okay? I should have really wrote it like that to make it more clear. But once you do that, what does that become? That becomes a, if I write it this way, you would get a u to the 4 minus u squared du, okay? And we know that is all over the interval of a half and 1. So now if we integrate this, what do we get? Well, we get a u to the 5 over 5 minus a u to the 3 over 3. And with our limits of a half and a 1, we now just put those values in. And if we put those values in, we get a 1 over half to the 5, which is 1 over 32, divided by 5, minus a 1 over 2 cubed, that's a 1 over 8, divided by 3, and that would be minus a 1 over 5 minus a 1 over 3. If we work this all out, we would get a 1 over 32 divided by 5 is the same as saying 1 over 32 times by 1 over 5, so that'll give us a 1 over 160. And then doing the same thing with this, we get a 1 over 24, okay? And that is minus a, well, let's just do it in 2 stages. So we get a 3 over 15 minus a 5 over 15. If you work it out on your calculator to save time, that 1 over 160 minus 1 over 24 would give you a minus 17 over a 480. And then with this one, that would just be, well, we get a 3 minus a 5, so that gives a minus 2 over 15, but it's being times by that minus, so we get a positive 2 over 15. And then that would be a minus 17 over 480. If you put that 15 over 482, you have to times it by 32, so you get a 64 over 480. And then when you look at that, we get a 47 over 480. And that is where we will end this video today. Hope you enjoyed it. If you want to see some other videos on integration, I'll leave the playlist in this end screen right now. So yeah, if you want to watch any more, just feel free to watch them. Yeah, I hope you enjoyed this lesson, and I will see you on the next.